All right, we begin with some light calculations. Again, we know some things about light. We know that the frequency, the speed of light, which is equal to 3.00 times 10 to the 8th meters per second. Actually, on the homework, use 2.99, I think it's 998 times 10 to the 8th meters per second. It can be kind of picky, so that would be a better one to use when you're doing the homework. But for my purposes, 3 times 10 to the 8th is fine. And that is equal to the wavelength times the frequency. The wavelength has to be in meters, and the frequency has to be in hertz, which is also known as inverse seconds, 1 divided by second. And then we also know that the energy is equal to Planck's constant times the frequency, and the Planck's constant is 6.626 times 10 to the negative 34 joule seconds. Okay, so the first question is asking us what is the frequency, and remember the symbol for frequency is the nu of green light, 540 nanometers. Again, I see a distance. So this is my wavelength. So I want frequency, I have wavelength. The equation that has frequency and wavelength is this one. C equals wavelength times frequency. Now I want the frequency, this is my goal. So I want to isolate this, which means I'm going to divide both sides by the wavelength. And I will end up with frequency is equal to C over lambda. Okay, so my frequency, my C is 3.00 times 10 to the 8th meters per second. And my wavelength, remember I need frequency, so I need to get units of hertz, which are inverse seconds. And I've got, so that one will I want that left, so I need to cancel out the meters. Note that this is not in meters. I have to convert to meters. And I know that nano is the multiplier 10 to the negative 9. So I can just replace the nano with 10 to the negative 9. So I'm going to put 540 times 10 to the negative 9 meters. So I've effectively replaced the prefix with its multiplier so that I'm essentially doing the conversion as I'm doing this. Make sure, because I have two things on the denominator, that I put parentheses around them. The meters are going to cancel, and I will be left with 5.55 times 10 to the 14th, and it will be 1 over second. But this is a hertz, so I could also say that this is 5.55 times 10 to the 14 hertz. And sig fig wise, this is really just 2 sig figs, because technically if I did 500, if I meant 540 with 3 sig figs, I should put a dot there. But we're not worrying too much about sig figs right now. What wavelength is KSLU's radio frequency, which is 90.9 megahertz. So it's asking for wavelength. I'm going to stick with our plan of goal. So our goal is wavelength. And I'm given hertz. This is a unit of frequency. So again, the equation that relates them is C equals lambda times nu. And this time my goal is this one, so I'm going to divide both sides by frequency, and I will get that the speed of light divided by the frequency is equal to lambda. So flip sides. So my speed of light, 3 times 10 to the 8th meters per second. And again, I want to be left with something in meters for wavelength. So I'm going to take this, I want the seconds to cancel. So I really don't want to use megahertz. I want to convert this to invert seconds. But 1 hertz is that. So I really need to get it into hertz. Once again, I know that the mega is 10 to the 6, so I will use that same trick, 90.9 times 10 to the 6 hertz, but I'm going to, instead of using the words hertz, I'm going to use 1 over seconds so that I can see that the seconds are going to cancel. I'll be left with meters. And I get 3.3003 meters. So we would report 3.30 meters. In this question, it's asking me for something a little different. It's asking for energy. This is my goal. And I'm starting with, this is a distance. And because I'm talking about photon, this is referring to light. When I think of distances of light, this must be referring to the wavelength. Again, it's not incredibly obvious, yet because I'm working with photons and I know I'm dealing with light energy, I'm thinking it's either going to be energy or frequency or wavelength. And this would be a unit of length, so this is my wavelength. Okay, so now I go back to my formulas. I know that C is equal to lambda times nu, and if I could say that nu is equal to C divided by lambda. I also know energy equals H times nu, and H is 6.626 times 10 to the negative 34 joules seconds. C is we might as well do it. 2.998 times 10 to the 8th meters per second. All right, so I want energy. So in order to get energy, I have to use E equals H nu. But I'm not given nu. I'm given wavelength, right? Wavelength is the lambda. So I'm going to use this. I'm going to replace this. But I know that V equals C over lambda. So I can go ahead and put that in here. I'm going to substitute it back in, and I get E is equal to H times C over lambda. And now I can use that as my formula. Okay, so C is 6.626 times 10 to the negative 34 joule seconds. C is we said we're going to use the 2.998 times 10 to the 8th meters per second. Note that my seconds will cancel out. And then I'm going to divide by, once again, I need the meters to cancel. So I'm going to need this in meters. So I'm going to use the nano is equal 10 to the negative 9. This is 638 times 10 to the negative 9 meters. So now my meters will cancel out. And I'll be left with joules, which is good because joules is an energy. And I get 3.115 times 10 to the negative 19 joules. We would round that off to 3 sig figs.